Hey everyone, welcome to this explainer. Before we even look at a single line of code today, I want you to picture something in your head. Imagine you're walking into a traditional old-school classroom. The desks are literally bolted to the floor in these neat little rows. There are exactly 30 seats. That arrangement is completely fixed, right? You know the exact capacity before a single student even walks through the door. Well, now contrast that with walking into a grocery store and grabbing a shopping basket. That basket is totally dynamic. You might toss in an apple, maybe add a box of cereal, suddenly realize you don't actually need the cereal and put it back. The contents shrink and grow as you go. Today, we're bringing that exact concept straight into computer science. We're going to master the difference between storing data in fixed, rigid structures versus flexible, dynamic ones. Yep, we're talking about arrays versus lists. Okay, so let's quickly map out our roadmap for today. We'll start with the big picture, then look at Python versus Java syntax, move on to modifying and traversing data, then choosing the right structure, and finally we'll wrap up with common mistakes and tips. Let's dive right in.
Section 1. The big picture, understanding arrays and lists.
So think of those bolted-down classroom desks as arrays. An array usually stores values of the exact same type in indexed positions. And crucially, in a lot of programming languages, its size is fixed the moment it's created. You use arrays when you know the number of items completely in advance. But on the flip side, we have lists, or in some languages, array lists. These are our shopping baskets. They're dynamic. Elements can be added or removed while the program is actively running. This makes them highly flexible for changing collections of data. So the absolute core takeaway here is arrays mean fixed rigidity. Lists mean dynamic flexibility. Now, what do these structures actually look like in practice? Well, we generally deal with two dimensions. A 1D structure is just a single row of elements. Think of a simple list of test scores. You access them in a straight line, right? Score 0, score 1, score 2. But a 2D structure, that's a table-like grid with rows and columns. Think of a movie theater seating chart. To find your seat, you need to know both the row and the column. And honestly, no matter if it's 1D or 2D, we frequently need to do something called traversal. Traversal just means going through each element one by one, typically using a loop to check or update the data.
Moving on to Section 2, Python versus Java syntax, how languages handle structures.
Okay, so Python natively uses lists, which are inherently dynamic right out of the box. For a 1D list, we just use square brackets to hold the names Anna, Bo, and Chen. And for a 2D structure, like a game board, it's essentially just lists nested inside another list to create those rows and columns. Now, remember, Python starts counting at 0, so asking for index 0 of the names list returns Anna. And for that 2D board, asking for index 1, then index 0, returns the number 3. Always row first, then column.
Java, however, handles things differently. It gives us two very distinct tools, forcing us to choose our weapon carefully. First, you have the standard Java array. See those curly braces? Once that array of scores is created, it is completely fixed. It holds those 3 integers forever. But if we want our dynamic shopping basket in Java, we have to specifically call on an array list. Notice the syntax shift here? We don't just use brackets anymore. We use specific methods like add and a 2 to put things in and get 0 to take them out. Basically, arrays are faster and simpler for fixed data, but array lists are absolutely required when you need that dynamic flexibility.
All right, Section 3, modifying and traversing data, seeing code in motion.
If you're working with a dynamic list, there are 3 essential operations you're going to be performing constantly. Step 1 is adding data. In Python, we use append super easy, which sticks an item right at the very tail end of the list. Step 2 is taking data out. We use remove to find a matching value and delete it entirely. And step 3 is traversal, which we touched on earlier. We use a for loop to step through the list from beginning to end, executing some sort of action on each element. Let's actually trace this step by step because it really helps to visualize the code. We start out with a list holding pen and book. That's our current state. Next, we run an append command for bag. Notice how the list literally transforms. It stretches out. It's now pen, book, bag. Finally, we run a remove command for pen. The list dynamically shrinks, leaving us with only book and bag. Tracing is literally just mapping out this changing state step by step. Okay, let's put your cognitive skills to the test with a quick Java scenario. Imagine we're building a queue, like a line of people waiting, using a dynamic array list. We add Ali, then we add Bo, then we add Chen. But then someone decides to get out of line. We run the command remove 1. After that happens, we run a loop to print out whoever is left. So pause and really think about this for a second.
Based on this specific cue, which person gets removed, and consequently, what exactly gets printed out to the console.
Did you fall for the trap? The answer is that Bo is removed. Remember, we use zero-based indexing. Ali is at index 0, Bo is at index 1, Chen is at index 2. So, removing index 1 means Bo leaves the queue. That means our loop is going to print Ali and then Chen. This perfectly highlights why array lists are so amazing for changing queues. The list simply collapses and resizes itself automatically the second Bo leaves.
Section 4. Choosing the right structure. Scenarios and applications.
When you're evaluating real-world software requirements, you'll often need to justify why you're using a specific structure. Here's your first scenario. You're hired to code a school timetable. It's a grid, it has exactly 5 days of the week and 8 class periods per day. This structure is known entirely in advance. Think about what we've learned so far. Do we need a fixed or dynamic structure? Do we need 1D or 2D?
The absolutely correct choice here is a 2D array or a 2D list. Why? Because the shape is totally fixed. A 5x8 grid isn't going to magically transform into a 6x9 grid in the middle of third period, right? It's table-like, so the two dimensions map perfectly to our rows and columns.
Now let's contrast that with scenario 2. You're coding an e-commerce website. You need to design the shopping basket that tracks what a user wants to buy. As they browse the site, they're constantly adding items, removing items, maybe changing their mind entirely. What structure are you going to apply here?
Your best choice is absolutely a dynamic list, like a Python list or a Java array list. And the key justification, the literal magic word you want to use here, is flexibility. The size of the basket changes during execution. A fixed array would either run out of space or completely waste memory by being way too large. The dynamic list perfectly handles that fluctuating size.
Finally, Section 5. Common mistakes and tips. Cheat codes for success. I promised you some cheat codes to avoid losing easy points, and here they are. Mistake number 1, mixing up index positions. Seriously, do not forget that both Python and Java start counting at 0. Mistake number 2, trying to tape together 2 separate 1D lists instead of just using one neat 2D grid. Honestly, it's like trying to eat soup with a fork. Technically possible, but just incredibly messy. And mistake number 3, approaching a clearly dynamic problem, like a waiting room or a shopping cart, with rigid, fixed-size array thinking.
So how do we fix this? Here is my practical advice for you. Tip 1. When you're tracing code on paper, physically rewrite the entire list after every single add or remove operation. Do not try to hold the changing list in your head. You will make a mental error. Just write it down. Tip 2. When accessing a 2D structure, drill this phrase into your brain. Row first, then column. And tip 3. If you ever need to justify why you use an array list or a Python list, always lean on the word flexibility to describe how it beautifully handles changing data sizes.
Which brings us to our exit ticket. Take a look at the real world around you today. Can you come up with your own original scenario perfectly suited for a 1D list, and maybe another scenario that's practically begging for a 2D structure? Try to visualize the rows, the columns, and the dynamic changes in your own everyday life. Thank you so much for joining me for this explainer. Keep practicing and start applying these concepts with confidence.